Hello everyone, and welcome to today's live stream, where I will be doing some more particle slash simulation nodes, now that I have the 3.6 simulation build. Now this is not the official version just yet, that would just be in the normal 3.6 build, which hopefully will be coming this upcoming week or 2 weeks, I don't know. But since we do have an experimental build that is available, I'm going to start using that. Since we get this very nice, all the benefits of 3.5, which include this very nice reorganized menu to pick from, which has, it's just much more organized. You get the read, sample, write for mesh, curve, instances. Well, not instances because there's not enough in there, but it makes it a lot simpler to do stuff. Unfortunately, I use mostly the search functions in my quick favorites menu, so I'll be using that a majority of the time. Ooh, there's a new selection input for the store named attributes. Well, probably. That may be useful in the future. I'll have to see about that. But yes, welcome, and my plan for today is to make a particle system that... Let's see, how would I describe this? Particles that spawn in, but then they have a target position, and then they go to that position over time, hopefully in a appealing way. So first of all, I need to get some points. Let's distribute points on faces. Plug this into here, so that goes into our simulation. Yep, there we go. So I'm going to do a few things. So initially I'm going to set the target position here. I'll have this as T-pose for target position. I'll set this to, let's just have this be 0, 0 for the time being. So let's set up the physics system. Let's use a set position. Plug this into here. And now we need our attribute, our velocity attribute. So I'll label it vel for that. And then I'll put that in here as well. And then I'll use an add. Plug that into there. So now we have some velocity, but we need to apply that to the output position. There we are, and that's looking fairly good so far, but we need to actually make the, make it go over to the target position, which is going to be 0, 0, which actually for here is local to the origin point. So I'll just move this over to here so that they will spawn in over here and then move towards 0, 0, because the origin is in the center. To do that, it's fairly simple. I just need to use the named attribute T-pose, and this could be any shape. So in the future, I'm going to make this like a cube or a circle or anything like that. I'm going to use a subtract right here. So if I do that, oh boy. Let's see. I need to remember how to properly do it. I think I know why it's freaking out, because this sends it the exact distance over, but then it gets added and all that. So what I need to do is scale it down so that it will go over less than the entire length of there. If I do that, we can see it is trying to go to the endpoint, but it's having a little bit of difficulty. And that's because it never slows down. So let me do this and then set this to scale. Actually, I need to put the scale before everything else. Let's set this to 0.95, and we should see eventually it'll slow down to, something reasonable like that. So with that, let me set it to 0.9, or let me set it to, there we go. So it'll go there, but then it'll do that. That seems good. Let me put this into a frame. That's good. The node editor feels like it looks different in the new 3.5 version. I can't place my finger on it. It just feels a little different, but it feels better, cleaner in a way. Another thing that I can do is add in a normalize after we get our vector from the target position after it gets subtracted by there to get the angle and then the length of it. If we normalize it, then this will mean that I'll go a set distance that we specify by the scale, rather than half the length, or in this case 1/10 of the length. So here we can see it's a lot more even they go at a constant rate to where they're supposed to. But the thing is, now they won't slow down. So this is a matter of personal preference. Because like this, it's like it starts off really fast and then it slows down. Do we want that? I'm not entirely sure. Not entirely sure. Yeah, there's that. And now since we have this is basically the entire node setup. So I'll put this into a frame. And then this one into another. Pretty simple, not the most complex node setup. But what if I want the target position to be different? Let's add in a random value. Let's have it so that it'll go into random... The target positions will be randomized inside of a 2 meter by 2 meter grid. So we do this, we should see, it takes the form of this, which is very interesting. But now I want to make it so that it'll go to points along the surface of this object, which will be interesting, because how do we define where the points should be placed? We could, let's bring in our cube into here. If we use a, let's see, a proximity, so that we can get the position, it's sampling it from over here. So it's saying, oh, where's the closest point to that? So it'll just go literally right to there. And this value does not change with the simulation, just so that you guys know. But I'll have to see. Like, we could put in a source position. This could be like a random value or something like that. And then this needs to be added to the position. So the source position is the position. Actually, no. We don't need that because it's just, oh, it'll go to a random point on here. So here we can see that does happen. It's going to random positions on the surface. This is just used for like scattering. So it places the points randomly inside this 1 meter by 1 meter volume. Then it gets the proximity, or the position in this case, of the surface, and then it sets that as the target position. That then the simulation just goes, okay, go there. And it does it quite well. Now the thing is, I do want to try something. I use a normalize after the fact, and then scale it according to the previous length here. I want to see what the result is. It could be cool, or it could be, like, horrible. Ah, okay, that's the issue. Since yeah, okay. There was a way, I forgot how, to make it so that the particles will, like, rotate back, like, they'll change their course and then go back to where they're supposed to be. But I forgot what that was. Let's see. Because I want it to rotate. You think, what if I do? Well, that won't change a thing because it's doing the same exact operation. I need to think about that. Because if I just take that in there... Let me think about that for a second. Because if I just delete this and then set this to like 0.1, we should see that that does kind of happen. Where they go forward and then, oh, yep, you can see they're like rotating back into place. So it does kind of work. But the speed is no longer dynamic. So you have this very interesting effect right there. Interesting. Well, this is another kind of setup for that, so let me copy this over so that I don't edit what already works. So let me do that. Let me delete that and that. So I'll normalize both of these beforehand and then mix between those two so that the rotation will be mixed between what it's already doing and then the new kind of angle that it should be going at. So let's use a mix for that and that. And then the output, I'll normalize it again just to be safe, and then set its speed, shall we say. So if we do that, we should see, yep, that happens. But if we lessen it by quite a bit, we can see that, oh wow, yeah, that is interesting. That happens, and then they kind of They should be going back about now. There they go. Okay. Ah, and that rotation happened rather fast. A little too fast, in my opinion. Well, let's set that to right there. Let's do that. And then they rotate, then go back to where they're supposed to. And they don't slow down, unfortunately. Maybe I should make the speed based on the distance to this position. So if I get the length, I could set like the minimum and maximum speeds. Like this. I know the node tree is getting just a wee bit complicated. But yes, the length right there, and let's put that into the scale. So let me just set this up so that's a little more understandable. So we have that, that, and that. So they'll go out, they'll turn around. When they go back, the speed narrows down by a lot. I think, do I add the velocity to the position? Would that make the proximity to this more accurate? I'm not entirely sure. Because it seems like the speed kind of builds up and then just goes vroom out into nowhere. Let me try that. If I add the velocity, let me copy this into, whoops, wrong one. Huh, I copied that. Control C, Control V. Okay, there we go. Need to make sure I actually hit the keys when I do that. If I do this, okay. Because that keeps the velocity going. Let me change this up a bit. There we go. So we can see they're kind of... They still go through, which I'm a little bit surprised by. But it's kind of working a bit better. Is the speed too much? This is the research and development section of it. We can see that that does not work, because that is not supposed to be happening like that. Is that... Because that makes the angle correct. Wait, why is that working? Okay. I guess that works now. Not entirely sure why, but... Let's hit this to like 0.1. Interesting. Very interesting. I do not understand. I'm not even sure if that's the best method to do that. Because I do like that a little bit better, but I think we can randomize the scale of that. So random value. We'll set this to be the drag force. There we go. So we'll do that so that there's a little bit of leeway when it comes to that. I'll just put this in a framing up there, just out of the way, in case we revisit it. So there's that. But what if I were to add in some noise? You guys know the drill for this. Put in the position, then have this be a noise texture. Subtract, vector mount subtract by 0.5, so that affects in the positive and negative directions rather than just the positive. And let's scale that by like, I don't know, 0.1. Feed it into here, feed that into the output. We should see some noise happening, which is good. Change the detail down because that's a little unnecessary. Let's do that. Maybe change this to like 3. Maybe I should put a limiter on how fast these can go. Because it seems that there is a... It goes a bit too fast. For the time being. And let's change this to another object. Let's have this be the classic monkey. Let's just place that in generally the right location. Let's change this from solid to wireframe so that we can see where these get placed. So they go there, and they eventually settle where they're supposed to. Should I put that beforehand or after? I don't know, maybe more animation after the fact would be good. And let's also multiply the amount of particles times 10 so that we can see the effect, because eventually this is going to be quite a bit more, maybe like a hologram in a way. So now that we have this and that, I was going to do something. Oh, right, the speed limiter. So for that, I would just do that, but then get the length of there. And if I were to plug this into there right now, it would have basically the same effect. But I want to set a map range for the maximum and minimum speed values that this can have. So minimum is 0, maximum is 1, but I want this to be a maximum of 0.1. There we go. That's a bit better, not quite as speedy. So there we go, there's that. Hopefully not too difficult to follow along with, if you guys are following along. Let's set this to 1. How does that look? Looks kind of cool. Again, they're going to their target positions. Which, how do I set the target positions to be what I want? Because right now they're just choosing a random point on the surface to go to. Well, they go to a random point, and then they say, hey, where's the nearest point compared to this? And then they go there. So yeah, I don't know. Let's go and make this a sphere at the moment so that we can clearly see what's going on with that. So here we should see they pick a semi-random point. Where are those parts? That's in line with the noise. Should I have the noise affected beforehand? Oh, right. If I remember correctly. Okay, let's do all the modifications to this beforehand. And then the target position stuff happens last. If I get this correct, which I'll need to double check if I do, I need to add to this, but it needs to be the most recent velocity. Let's make sure that works. No, it looks the same. Okay, let's not overcomplicate it. Alright. I should mention that I don't know if this branch is going to crash a lot, so if it does, oh well. Let's see. Can you make the Avengers Assemble scene in Blender? No, I do not have a multi-million-dollar budget, and I do not have access to Robert Downey Jr. If I did, I would. Yeah, I don't know what you mean by that. There are many Avengers Assemble scenes in Blender. Not in Blender, but in the movies. Because if you mean the Endgame one, I would need lots and lots of money that I do not have. Alright, so now they could go there. Now, how do I make it so that it switches which object it's going to go to? I don't know. Well, let's go and make it so that more particles spawn in, but it's in a wider plane. This might lag. Ah, there we go. A few too many particles, so let's reduce that. Let's move our mesh of interest up by quite a bit. Set that to relative. Ah, they're going to the bottom because it's referencing the closest point. Not the best, not the worst. Actually, what would happen if I sampled sample index? What if I sampled the position from the index? This would make it so that it would go to one point on the sphere, but there'll be some redundant ones because there's more particles than ones on there. Ah, there we go. So the ones that can go to that position do. The ones that have no position to go to 0, 0. There we go. So there's that. That could be useful. Maybe I need to make it so that some of the particles, like, recycle in a way. But that's an interesting side effect. But not bad. I mean, yeah, the particles go where they're supposed to, and the ones that aren't supposed to be there just go away. And I could auto-trim the amount of particles so that the only ones that simulate are the ones that have a place to go to. I could just delete all the ones down there before the simulation even happens. Which may be a good idea. Let's switch this back to the monkey. And let's subdivide that. Let's watch what... Subdivide, not solidify. There we go. So let's take a look. There we go. Chooses to... Wait a second. Did I not... Okay, there we go. But it looks like it's missing a few of the face positions. What if we did make it face positions? Interesting. Well, that's an option. There we go. Is that C418 in the background? Most likely. It is Minecraft music. Calming Minecraft music. So now I'm going to implement the particle trails. Actually, let's go up and set up the render scene a little bit before I set up the actual trails of this. I'll go and remove the floor so that we can see what's going on a bit better. So let's instance on points. I will instance, let's see, a mesh primitive. I really like this new layout. It's just like mesh, go to primitives, and then you have everything right there instead of a list that is super duper long. Primitives, let's go to cone, because cones just go up and down, so let's do that. Let's set this to be like that, maybe the depth to be 1, the radius to be like 0.1. So now we need to orient them in the right way, so let's use the velocity, using a line Euler to vector node, plug that into there, set this to Z, plug it into the rotation. Now if we look at this, they're pointing kind of in the right direction, but they need to go the opposite way, so I'll set the depth to -1. So it'll be like that. And then for the scale, I'll just get the length of the velocity. That means basically the distance that it travels from one frame to another. Plug that into there, which means that happens. They'll get bigger as they go along, but then they'll shrink over time. If I use a combine X, Y, Z and have this only on the Z axis, I think it would look a bit better. So let's do that. This means that they'll stay at a constant width over time, but the length will change. Oh wow, that looks kind of weird with denoising. Let's turn that off. Let's make a new material and then apply that material. That's material. There we go. Let's plug that into there. So we should now see, once I set this to emission, there we go. It's now looking like actual particles this time around. Let's set this to more of an orange. Give it a little bit of glow. Something like that. Maybe let's turn up the points there for a bit more. So that does work. I could make this an icosphere, but I like the cones because you can see, like, oh, there's a clear trail happening. Actually, let's try an icosphere. Will it look better? Let's give it a try. Okay, let's set that to like 0.1. I would need to multiply the length in order to be better, or I could just, like, set that to be smaller. Oh, no, I like that more. Okay. Ooh, and we get UV maps for the icospheres and all the other spheres. Oh, that's nice. I've been waiting for that for a long time. There we go. So we have that happening. The one thing I don't know is why it's not looking the glow. Oh, there we go. Now the glowy stuff is looking more glowy. There we go. So now I'll take the form of that object. I like the index look a bit better. Now, one thing I could do is constantly update the position, the end position that it wants to go to every single frame, so that I can make it move along and then it would follow suit. So let's try that. T position for target position, but just put it inside the simulation. So if I do that, I'll do that. Then I'll be able to move this around if I want, and then it'll try to follow to where it's supposed to go. But that also means I could switch which object it'll be referencing. So I can have several objects in here, and then it'll switch between which one it wants to go to. Okay, so let's give that a go. Let's have several objects in a collection. No, let's just have several objects in the scene. Let's subdivide this one. And let's not apply it. But I will set this to wire so that we can see what's going. Ooh, wireframe is broken. 3.6. That's cool. They'll fix that eventually. Let's go back to here. Let's have the icosphere be in here so that we can switch between one mesh and another on the fly while the simulation is running. So if I have this going, then I click that. Excuse me. You also have the clamp off. Switch. Oh, set that to relative. There we go. So it switches to the icosphere. And then there. So it goes to the monkey. Then it goes over to the icosphere. Then back to the monkey. Now all of the particles that don't get used just go to 0, 0. I could switch that up. So one thing, let me do this. So I'll have the mesh selection process over here, but the actual thingy here will do the thingy. If I get the domain size, let me put a reroute here. I could wrap the index so that once it gets above the point count, it'll just loop back around so that they'll just... None of these will be left alone, but it seems like some of them are. So maybe I need to... Oh wait, it's base count, is it not? No, a few of them. Let's set this to point and this to point as well, just to make sure. So that happens, but I think I may need to add one to double check. Add or subtract one. Okay, so I needed to subtract one in order to get that to work. Interesting. So that does what it is supposed to do. That goes to the vertices. What if I were to... There's many things I could try to do with this, and it would be amazing. Okay, so let's... Yep, no vertices go to waste. They do double up on the endpoints, but that is fine. Completely fine in my opinion. Let's do that, and then back to there. Yep. I could do several things just to make it a bit more interesting, shall we say? No, this is fine. This current version is fine. Let me hide all the unused sockets there. There we are. So let's do that. Switch the object once again. I could have it switch between more objects, but I think... I could have objects in a collection. Yeah, this would be better. Okay. Let's put these guys into their own collection. Collection 02. Now let's have... Where's the input group? No, scene collection info. I really like this new menu. It's so much more organized. It's like, okay, what would be input? Scene. Okay, there we go. Much better. Collection 2. Separate children, but not reset children. And then we use realize instances, but there's something else that needs to be done. I need to select which one. Let's use a separate geometry. Let's have this be instances so that I can use index, but let's make this equal. There we go. So now it'll only have the right one in here, and then I can select that, then that, and if there's nothing in the scene, it'll reset to that. So there we go. Now instead of having to manually add them all, I could just have a simple collection, doing their thing and being happy. Let's go and put that in a nice little group right there. There. And then there. And then if there's nothing, it goes to 0. So now I could add in more of these. So let's go and add more. So let's add in a torus object. Let's set these to bounds. Just so that the shape will be revealed not from the wireframe, but the object that goes to it. Oh, and that the torus is not in the collection, so let's go and put it in there. So there we have that. So it goes there, and then it goes to the torus. Very nice. Now if I wanted to randomize the points that they're going to instead of just that, that would be... I need to figure out how to do that. Because I have an idea. And that idea is to, like, sample the face, like the position of the face, as well as the points, and then interpolate based on that. Which may be a good idea, but I'm not sure. Yeah. Let me try this again with the other method. The rotate into place. Oh, wow, that was way too fast, but... Okay, let's go and change this up by a bit, and change the max speed to 0.2. There we go. Okay, they go into place, they're doing their thing. Ah, and then they just scatter. Which again, I don't know why that happens. So they go into there, then they go into here. I really like how they rotate into place, but there are issues with the velocity when that does happen. It's a shame, really. Like, look at that. They just go into place as they should. Like, they go there, but the thing is their velocity just doesn't really stop. But there may be a little bit of a cheat in order to fix that. Man, that'd be random value. Just offset this ever so slightly. You may make it so that they... Any moment now. And maybe I need to put in the scene time frame so that's randomized every frame. So that they decide to go where they're supposed to. Because that should not happen. 0.5. I do have a minimum speed. Maybe I should just set that to 0. So that does happen. Okay. Well, crisis averted, I guess. And I'm going to change one more thing. I'll put a minimum scale, which, ironically, you have to use the maximum value to do that. I don't know why. But just so that these can not get any smaller than that. So that they'll actually turn into points when they do their thing. So here we have this. This is a pretty solid setup for 30 minutes in. Not bad. Not bad whatsoever. Now I may want to, you know, multiply this after... multiply after the fact. Actually, I could just set that to 1, 1, and 1. No. I don't need that right now. Okay. Keep it simple. So we have that. They go into place. And then I do a little switcheroo. Then it goes where it's supposed to be. Maybe I'll add in a random value to this, so that they don't all follow the same exact pattern. Set this to 0.2 and 0.1. And I do not need that, apparently. Wait, did I just not connect that? Wait a second. Uh-huh. Okay, very odd, but looks like I don't need that, which will make this simpler for me. So we have that, that, and that, which I could just collapse the mix in order to make it look a bit better. So let's put this over to here. I'll put that there just so that's cleaner for you guys to see. Let's see. Yep, that seems to be good. I do like this method where they go into place even though it is absurdly slow. Let's make that like 0.01. There we go. Is that better? So that they go there and then they just slow down into place. Looks kind of standard now, no real like bounce back or anything like that, but I'm kind of alright with it. Then when they go to a new place, they do the little rotation thingy to go there. Okay, that's just a little bit of a problem. Okay, they do that. They'll go into orbit. Like those ones, they go into orbit. And they won't settle down. Because they're in exactly what I said, in orbit. I do like the way that they do that. So either or is okay. But I do like the kind of jostle into place. Why are they orbiting? Right, because of the noise. If I turn off the noise, then they just go into place as is. What if I did that rotation thingy? Well, it was... Yeah, let's try that. But only the noise does it. So let's do normalize. But then we'll mix between that. Or, no, we'll just add the noise to it. Then normalize it after the fact. So normalize, add, normalize. And then it'll be scaled according to the previous length. I know this is a little complicated, but it works. So normalize is like, oh, set it to... yeah, I should explain this. Normalize basically says, hey, set it to 1, 0, or -1. And then I add to this from there, normalize it again, so that it's basically a vector now. Then I apply the original speed, shall we say, or the power of this vector back into it. So we're only changing the rotation, not the speed. So if we do that, what happens if I bump this up by quite a bit? Have we found the answer? I think we have. Oh, that is beautiful. That's the way to do it, folks. So with our little rotation manipulator right here, it works pretty darn well. Put this here. Control J. So this is, I'll just name this rotation. Or no. Rotate. I could just use a vector rotate for this, couldn't I? Let's see if the results are the same. So let me use a vector, whoops, vector rotate. Have this be Euler. If it gives the same results, then I am just a little bit dumb, I'd say. And it does. Okay, scratch all of that, folks. You could do it in one node. I just never learn, do I? It's like, oh, you probably could do that in just one node and it would be fine. Like, look at that. I think some of these are in orbit now, but, you know, we could just have it, you know, reduce over time. Yeah, some of them do arrive in orbit. Wait, does orbit ever happen with the previous version? Let's give that a go real quick. Are some of them in orbit? Okay, they do slow down, but what if I turn it up by a lot? Yes, some of them do get into orbit, but we get this really cool galaxy effect. But what happens here? Oh, wait a second. So this does give a prettier result. Huh. Orbits do happen, but not nearly as often. Actually, it looks like it still happens fairly often. But if you stay below 1, I think it stays good. Oh, with the vector rotate. It seems like both of these may be valid, but... yeah, okay, so it seems like this one is prone to orbiting, while the other one is not. Even though that does settle down in a very similar way. So both of them are valid. But if it's like this one has more of a limiter to it. And it gives a really cool side effect. So really, it's up to you which one you want to do. If you want to go the simple route, you could just have the vector rotate. If you want to go the more complex route, you could use whatever the heck this method is. It would still be good. So with this... oh, does the Eevee bloom seem a little bit different as well? It feels different. Huh. Did they change it? I'll have to test. Yes, it feels different. Still looks good. But it feels more like a camera sensor in a way, because it kind of gets a little bit discolored. I'll have to do more testing, but if that is the case, is Eevee next an option? It is, okay. I'll have to do some testing with that. But with this, I think this is good for now. I may end the stream now, because we have the effect almost exactly as I want it to be. We have this very cool morphing between objects, doing their thing. Yeah, see how good that looks? That's fun. I do like that. It's quite good. I like it a lot. Emission changing with velocity sounds cool too. We can do that. Thank you for reminding me. We could get all of the attributes that we set in here. So let's get the velocity. Whoops, the velocity. But one thing that we need to do first is we need to set this to instancer, because all of these are instances. But now we can see we have the velocity. So one thing that I like doing is using not a normalize, let's use a scale instead. So let's do that, bump it up by a good amount, so we can see that in better detail. But you can see there are some like weird errors. That's because you're seeing the negative values as well. So let's absolute this, plug it into there. And now we can see that all of these are colorful because the negative values have now been set to be positive. There we go. We could also, if we use the length, we can get these just the speed. So we can say, hey, like if I use a color amp, like, oh, turn red at a certain speed or turn blue at a certain speed. But I do like this version. It's pretty nice. You can see all the nice colors before they fade into nothingness. Alright. And if I use a normalize, just to show you, whoop, sorry, normalize, just to show you, no, normalize, not normal, normalize, there we go. Normalize essentially says, hey, it doesn't matter what value it has, I'm setting it to 1 or -1. So the colors will change, but not the brightness. That's a good way to visualize it. So that's what the data looks like by default. Here's what happens if we use an absolute. It changes all the negative values to positives. Then normalize just says, hey, no matter how big the vector is, I'm just going to set them all to the same value. It equalizes it. Then you can see the values change once the velocity gets a little bit more randomized because it's only moving a little bit. So there you go, folks. That's how you do it. I would try this on an animated mesh, but I'm not really feeling it at the moment. Let's go to the cube, which is actually the monkey in disguise. Here we can see that. If there aren't enough particles in the system... Oh! We can see a little bit of an error emerging. I think in GeoNodes they messed something up, which is why not all of the vertices are appearing. Because if I were to apply this... No, it's still broken. Like, that's not the pattern that should be arising from this. Seems like some stuff is broken, but that's on Blender side, not mine. So I'm happy about that. It's not my fault. Let's just plug that into there, and then boom, we get that. I'll use them. I'll try something different. Let's just take the velocity. Control H to hide the unused sockets for both of these. So let's delete that. Let's use a map range. Say, hey, if it's going above, let's make this like between 2 and 1. Even though it won't be going to 2 at any point. So actually, I don't think we need the map range because these don't travel more than 1 meter per frame. So yeah, we don't need that. We'll just plug this into there. And we'll say, hey, if you're going really fast, be red. If you're going really slow, be blue. So fast is red, but as they slow down, they almost cool down in a way. Let's do that. So fast, and then they slow down. Let's change this to hue saturation value. There we go. So that, then it transforms into the cool blue. The blue looks very good. They must have changed something under the hood. So yeah, that little error where the vertices seem to be a little off. Actually, no, that might not be Blender. That might just be that there's not enough particles to go around for the entire thing. That's what I think's happening. Okay, so it's not... I don't think it's a Blender side. I think there's just not enough particles in this simulation to accommodate every vertice. There we go. Okay, that's better. I should set some of the scales to be random. That looks so good. Like, you see that? That is amazing. Just like that, and then all of a sudden, whew, in place. As it should be. Let me set this to be a little bit different. The one thing is that it seems to transition a little bit too hard to, blues. So let me change that up a little bit. Let me turn up the saturation by a little bit, just so that looks a little bit better. Those will do that. There we go. A bit more like that. There we are, so that happens, and then it goes into its final form. You should make the particles go to 0 velocity at one point. They kind of do. They just get less and less and less. Which makes it so that there's a little bit of motion, which I'm okay with. Let me set up some random scaling, and then I'll call this a night. Because we're almost at 50 minutes. Geometry node editor. Like, this part is not needed, so I'll just move it even further up. Vector rotate, we don't need that at the moment. We have everything we need right here, and it's actually not the worst in terms of node group size. I do organize this, so it makes it look, whoops, much, you know, not as daunting to deal with. But yes, I can scale this just by using a random value. It's not a good idea, though. Use a random value. Let's set the seed to be something a little different. It's not a good idea. Particles of all different sizes. I think, yeah, I think that is a good idea, but let's change the range for that. Because this is also manipulating the kind of motion blur scale, because it's affecting the z-axis as well. But I think in this case it's fine. Just the final touch. But that is a really cool effect, seeing like a ton of particles come together, and then it's just like, oh, I'm this object now. So cool. Let's try different color schemes as well. So I don't need that. I can delete that because it's, you know, not necessary in this case. Let's hook this up into there, turn that to there. Yeah, let's have this be more like that. Ooh, this could look good. I think these are too saturated, so I'll use a hue saturation value node just to reduce it in post rather than, you know, editing all of those by themselves. So by default, they'll all be super saturated, and I will change that as it goes along. And if you want some of the colors to be random, you could use just the object info node, look at the random output, then you'll see a random value for each of these. So I could, in theory, plug this into like the hue, set that to 1, so that these all have random hues, but that looks absolutely terrible. So let me divide this by a bit, just so that they have like some different hues in this case. Yeah, that doesn't look too good. So you could do that if you want, but I think I'll call this project done here. All of them fly around doing their thing, and the switching works just as well. There you go, you have a nice torso. And then it goes all the way back to the monkey. So I may use this for other projects. It's quite cool, I would say. Let's also, let's turn up the emission by quite a bit more, you know, just to get so much bloom. The bloom does feel different. Okay, that'll be all, folks. Hopefully you all enjoyed. I think this was a good project. Not the most complex one on the planet, but not the simplest. A good, I would say, medium in terms of geometry nodes. And that gives a very cool result. One that'll make you say, is that Houdini? Not yet. We don't have that just yet. Maybe in the future. Alright everyone, thank you all for watching this stream. Hopefully you were able to learn something from this. And yeah, this turned out as well as I could have expected. So thank you all. I will see you next time.